This is lesson 7.7, page 317, and it's all about area and mixed numbers. How can you use a unit tile, probably like a little square, maybe our cubes or our flats. A unit tile, remember when it's a unit tile, it doesn't have a specific measurement of centimeters or feet or inches or things like that. You would have to have that same unit tile to figure out the actual size. How can you use a unit tile to find the area of a rectangle with fractional side lengths? We're going to look at this today. Sonia wants to cover the rectangle floor in her closet with tile. The floor is 2 1/2 feet by 3 1/2 feet. She wants to use the fewest tiles possible and doesn't want to cut any tiles. The tiles come in 3 sizes. 1 foot by 1 foot. So you have a tile about this big. 1/2 foot by 1/2 foot. That would be about 6 inches, right? And 1/4 foot, which would be about what? How many inches? 3 inches. So you'd have a little tile about 3 inches that you could use. Choose the tile that Sonia should use. What is the area of the closet floor? It's 2 1/2 feet by 3 1/2 feet. And to find the area, we have to take the what? Length times the width. Okay? So the first thing we have to do is find out what that area is. Okay, that'll give you a clue on your paper about how to find the area. So we're going to go ahead and make these into improper fractions and multiply them. So 2 times 2 is 4, plus 1 is 5. So we have 5 halves. That's 2 1/2 put into an improper fraction. And then 2 times 3 is 6, plus 1 is 7 halves. Okay, so now we made this into improper fractions by taking our denominator times our whole number and adding our numerator. So we got 5 2/7 times 7, or 5 seconds times 7 seconds, which equals 35 seconds. Now, if we're going to divide this by 2, we're going to have a leftover tile, right? And since we're talking number of tiles, we need to figure out what we can use that will not, which remember she doesn't want to cut. So she's got that half of a foot left over. So what kind of tile do you think we should use? If she's got that half of a tile left over and we don't want to have to cut, what size of tile should she probably use? The half-foot tile. Okay, we're going to go back to your paper and we're going to write something in for our explanation. The 1/2 foot by 1/2 foot are the best tiles to use. The 1 foot by 1 foot tiles will not cover the whole floor or would hang over. So if you would get over to where you would have that 6-inch space, and you would have to cut that 1 foot tile or leave a blank spot or something. Remember, she wants to use the fewest tiles possible and doesn't want to have to cut any. And the 1/4 tile would also work, but she wants to use the fewest. And for every 6 by 6 tile, we would have to use how many 3 by 3 tiles? 2. That would just make a rectangle. We have to use 4 of them to cover the 6 by 6 area. So the best tile for her to use is a 1/2 foot by 1/2 foot. Okay, so now it's asking us to put that on the grid that they give you there. It says on the grid, let each square represent the dimensions of a 1/2 foot by 1/2 foot tile. So each one of those squares is our tile we're going to use. Then draw a diagram of the floor. So let's go ahead and let's go 2 1/2 by 3 1/2. So let's go. If we draw down our 2 1/2, there's a half, 1, 1 1/2, 2, 2 1/2, right? So you should have drawn down 5 tiles. And then we would go half tile, 1 foot, 1 1/2, 2, 2 1/2, 3, 3.5, and go back up, and you should have a rectangle on the top of your top left-hand corner of your diagram, and you should go over 3, 6, 7 tiles. Okay? So how many squares cover the diagram? How many down did we go? 1, 2, 3, 4, 5. And across we went 1, 2, 3, 4, 5, 6, 7. So 5 times 7 is 35 squares. And remember, that was the top of our improper fraction, right? What is the area of the tile you chose? Okay, it says what is the area of the tile you chose? Well, to find the area of something, we multiply its sides, right? So 6 times 6 is 36, or it is 1/4 of a square foot. Since one square on our diagram represents the area of 1/4 square foot, the area represented by 35 squares is 35 times 1/4, or 35 over 4, and 4 goes into 35 8 times, and then you would have 3 inches left over, and you would put that over your thing. So the area of the floor written as a mixed number is 8 3/4 square feet. 8 3/4 square. Okay, this is the draw the conclusion at the top of page 318. It asks you to write a number sentence for the area of the floor using fractions greater than 1. And if you take 2.5, like we did earlier, and put it into an improper fraction, it was 5.5. And if you took 3.5 and put it into an improper fraction, it was 7.5. Then it says, explain how you knew which operation to use in your number sentence. Well, we know that when we find the area of a rectangle, we have to multiply its side. So in finding the area of a rectangle, I use multiplication. So number 2 says, explain how using fractions greater than 1 can help you multiply mixed numbers. Okay? Well, it's easier to multiply. It says I can change the mixed number into a fraction greater than 1, or what we might know as an improper fraction, and multiply the numerators and the denominators. So this is number 2 on the draw the conclusion. Again, explain how using fractions greater than 1 could help you multiply mixed numbers. I can change the mixed number into a fraction greater than 1 and multiply the numerators and the denominators, which we did earlier in this lesson. Okay? If we go on to number 3, it says how many 1/4 foot by 1/4 foot tiles could Sonia need to cover 1/2 by 1/2 foot tile. Now, we talked about this also, that a 1/2 by 1/2 foot tile is 6 inches by 6 inches, correct? And if we're putting a 1/4 foot tile in there, how many inches on each side is a 1/4 foot tile? Remember that it is 3 inches by 3 inches. So if I come over on my drawing and I draw 3 inches by 3 inches, there is one of my 1/4 foot tiles, and 3 inches by 3 inches again is one of my 1/4 foot tiles, and I would be able to fit 2 more 1/4 foot tiles in my 1/2 foot tile. So how many 1/4 foot tiles would I need to cover the same closet for if it takes 4 1/4 foot tiles to cover the 1/2 by 1/2 So question number 3 is how many 1/4 foot by 1/4 foot tiles would Sonia need to cover 1/2 foot by 1/2 foot tile? And as I've demonstrated here in our drawing, it would take 4 tiles, and that's the answer to number 3. Now number 4 says, how could you find the number of 1/4 foot tiles by 1/4 foot tiles needed to cover the same closet floor? How could I do that? Anybody have any idea? Remember, it's going to take me 35 of the 6 by 6 tiles. And I need, for every 6 by 6 tile, I need 4 3 by 3 tiles. So how many tiles is it going to take to cover that? How many did we say it was going to take to cover it with the 6 by 6? Go back and look at it. Yes, but how many, no, how many was it going to take to cover our whole floor? Go back on page 317 and look at your answer. That it was going to, the area represented is 35. So it's going to take 35 1/2 foot for the 6 by 6 tiles. So it takes 4 of these to cover that. How are we going to figure out how many 4 by 4 tiles? If it takes 35 6 by 6, how many 3 by 3? What are we going to do?
Divide it by 2.
Why would we divide that area? It's going to take, one of these is going to equal 4 of those. And we want to know how many of this tile it's going to take. For every one 6-inch tile, how many 3-inch tiles?
1.
1. So 1 6-inch tile is equal to 4 3-inch tiles. So this is the 6-inch tiles. This is the 3-inch tiles. And I need how many of these? 35. What did I have to do to get 4? Over there to this 1. I had 1 and I equal 4. What did I have to do to that 1 to get 4? How did I divide?
Multiply by 4.
If I have 1, there you go. I multiplied it by 4. So what am I going to have to do here? Multiply it by 4. Okay. Okay, so your written answer on number 4 is I could multiply 35 1/4 foot tiles by 4, since it takes 4 1/4 foot by 1/4 foot tiles to cover 1 1/2 foot by 1/2 foot tile. Use an area model to solve 1 3/5 times 2 3/4. Rewrite each number as in the sum of a whole number and a fraction. So we're going to rewrite this as 1 plus 3/5 and 2 plus 3/4, right? 1 plus 3/5 is equal to 1 3/5. That's why it's a sum. Draw an area model to show the original multiplication problem. So you should draw a rectangle over to the side of your paper. Ignore this little one down here at the bottom. Maybe I can get rid of them both. And try that again. Okay. Okay, so did you draw your model? You should have drawn a rectangle. And it is 2 3/4, and we're going to put that on the top because that's the longest measurement. And 1 3/5. So that matches the dimensions of the size of our rectangle. It says draw dashed lines and label each section to show how you broke apart the mixed numbers. So, goodness. We're going to draw a dashed line to break this into 2 3/4